Hello, I'm Hans Zeller from Esgyn. In this video, I would like to demonstrate how we can integrate the R programming language for data and statistical analysis with the EsgynDB database engine. We'll show two things in this video. First, a simple integration where an R program reads data that is stored in EsgynDB using a JDBC interface. In the second part of the video, we'll show a more sophisticated integration. We'll take an R program, deploy it on all the nodes of the EsgynDB cluster, and then process data in a massively parallel fashion in a scale-out environment, and then bringing that processed data back via JDBC to the R program for further processing. Let's do a quick demo. So we have the R graphical interface here running, and first I need to open up some library that we'll need for graphical processing as well as for database access. Once we have those, we can establish a connection to our EsgynDB server. This looks very similar to JDBC, where we specify a jar file for a driver, a class name, and then a JDBC connection string. So with this connection, we can issue a query to the EsgynDB server and return the result as a data frame. Here you see the query. We are selecting latitude and longitude data from Starbucks store locations. So these are all the Starbucks stores worldwide. And the result of this query got written into this raw data frame in R. To visualize this, we can plot it with another R method called ggplot. And this is what this looks like. Kind of like an outline of a world map. So far so good. So all the R that we have done has been running on my PC here, and the SQL query has been running on the EsgynDB cluster. It basically looks like this. So that can work very well, especially if we can do a lot of processing in the SQL query and the R program really does the final analysis. However, in other cases, what might happen is that we would like to push our code into the EsgynDB cluster, which could be quite powerful, much more powerful than a client, and a scale-out environment, and parallelize that processing. So it would look something like this. We may still have an R program at the top to do, let's say, graphical displays, but we also want to run R on many or all nodes of the EsgynDB cluster. To do this, we have to write an R program that follows these three guidelines. The R program will need to accept a data frame as an input. It will have to produce a data frame as output, and it will have to be written such that the data that it processes can be partitioned, and these partitions can be processed in parallel, independently. In other words, it should basically look like a MapReduce program, like a mapper or a reducer in a MapReduce program. Okay, let's take a look at what this will look like in our R environment. What we basically did was to provide a user-defined function framework in EsgynDB that allows to invoke the R programs that are described here, and then the R program on the client side, as you can see here. This R program can then invoke this user-defined function plus any SQL statements, any SQL constructs it needs through the interface that we also used for our first example, the simple JDBC connectivity example. So let's take a look at what this looks like in the R graphical environment. So here we run a query on the cluster that will actually do the k-means analysis invoking a parallel R program. And then we take the result, these clusters, and we can plot these clusters as an output. So we actually see these are the clusters processed in parallel using R on EsgynDB, and this was the raw data with all the Starbucks stores. So here's the Starbucks stores, and here are the clusters of Starbucks stores. Now, we kind of ate the dessert before the main course, so I showed you the result, but let's look at how we got to this point. Specifically, what does the SQL query look like that we invoked? And also, what does the R program look like that we ran in parallel? So let's look at the SQL query first. This is the SQL query. It is basically a select from a UDF, a user-defined function, called filterprog. And this user-defined function takes several arguments. The first argument is an input table. This is a table-valued item that is basically the raw data to process. And then it takes the name of a script, which invokes an R program. I wrapped the R program into a shell script. Arguments to the script, which are none in this case, and some description of the output parameters, the output columns of this program. So this is what it was hard to see in the R environment because it was all written in one long line, but this is the query that I invoked and printed. And now here is the R program that gets invoked by this UDF. And that R program consists of basically two pieces. One piece, shown in green here, is a skeleton that's basically the same. You could just clone this for every such R UDF. This green skeleton, what it does, it reads input in table form. That's the input data frame. It then partitions that input based on some column or columns, and then loops over the partitions. And for each partition, it will do some logic. So first filters out the partition from the data frame, and then this gray code here is the logic to do the actual k-means. You see here the call to the k-means method. So the gray part is what will be different for every R program that you want to write. Finally, for each partition, it will write the data frame that's the result to the output. All these data frames for each partition, they will actually be later unioned together to form the table valued result. So this is in a nutshell how we can integrate R and EsgynDB, both for simple processing on a client machine and also for massively parallel processing on an EsgynDB cluster. Thank you.